All right, we're gonna do some additional problems on hypothesis testing today. But we're gonna take a different look at another value that you're able to calculate. This is, once again, this will give us some additional practice with hypothesis testing. Not that it's overly difficult, it's just a matter of you remembering what you have to go through with respect to hypothesis testing. Survey claims that the average cost of hotel rooms in Atlanta is $69.21. Obviously, this was not now, because now it's you can add a 1 in front of the 6, and now that you're talking maybe a 2 in front of the 6. Test claim, researcher selects 30 hotels, finds average cost is $68.43. Standard deviation of that, blah, blah, blah. So enough evidence to reject the claim. Well, the claim is that the average cost per room is $69.21. So we're going to set up our null and halt to the hypothesis like we've done in the past. And we're talking about mu. And he is saying the survey claims it is this value. Now, once again, as we've talked about before, when you're talking about is, it's not more than, it's not less than, it's just is this value. So equality is going to be thrown into this, but equality will always go with the null hypothesis. So we can set up our mu is equal to and not equal to the 69.21. So we have n is a value of 30. We have of the sample, the mean of the sample is 68.43. Standard deviation is $3.72. And we have an alpha value of 0.10. One tail, two tail. Two tail. Two tails, so we set up our bell-shaped curve. We get our two tails there. These, once again, are our critical values. We go to our t-table. We look up two-tail test. Two-tail test, alpha value 0.10. Find our critical values. Critical values are what? 1.65 and negative 1.65. That. Okay, then we go to our z-test value, which is x bar minus mu divided by standard deviation divided by square root of n. So we find our test value. So we have 68.43 minus 69.21. 3.72 divided by square root of 30. Once again, this process is not changing as we go along, and it won't change. Once again, quantify. Test value, Adam, what do you get for test value?
Negative 1.148.
Maybe 1.148, good with that? All right, so we take a look at where we're at. Here's our 0, negative 1.14, throws us in this region. Once again, the big region is non-critical. Then we have critical. And critical here, we fall in a non-critical region, so we fail to reject the null hypothesis. Average salary of public school teachers for a specific year is reported to be $39,385. Random sample of 50 public school teachers in a particular state had a mean of 41,680. Standard deviation of 59,75. Sufficient evidence at an alpha value of 0.05 to conclude the salary differs. Okay, write your null, write your alternate, go through the steps. Write your null and alternate. We have just the word differ, the key word is differ there. One tail, two tail, do your bell-shaped curve, find your critical values. what do you get for test value?
2.716.
2.716. So if we look at 2.716, we fall out here in the critical region. So we can reject the null hypothesis of your mean salary for teachers to be 39,385. So what you can do then is probably set and establish your new value of 41,680. Okay, once again, we've been there, done this. We've done this many times. Now this is where my old school philosophy differs a little bit from the newer age of education, which is, I was hooked on phonics. Your era of education is hooked on technology. Your phones, your Chromebooks, everything. You're hooked on technology. Okay, calculators also are thrown into that. That's technology. To me, this is a very simple process of showing the theories behind your hypothesis testing. It's easy to see critical, non-critical regions. Your test value is outside its critical values and so on and so forth. Years ago, went to the University of Findlay, because this is class to the University of Findlay. Had to go through a seminar during the summertime. Sat there in a classroom just like you. Us teachers that were teaching University of Findlay were students for the supervisors of us. Two ladies that were sitting there that were talking about, well, let's do a couple problems on the hypothesis testing and see how we approach this and how we deal with it with respect to kids. Okay, that's fine. So we went through it. I went through what I went through. They showed a solution up there that had absolutely nothing to do with what I did there. And all that they talked about is they talked about a p-value. We need to deal with the p-value. We can calculate the p-value, and this is what it is. And then we can make our decision based on the p-value. And I went to after they got done with all the explanation, I raised my hand and went, I'm sorry, I guess I'm not doing what I need to be doing here because I don't teach my kids p-value and looking at a p-value. I said, what do you mean? So I'm sorry, we go through our decision-making process this way. This is what we do. We find critical points, we find bell-shaped curves. It shows the kids what the meaning of bell-shaped curves are and the idea of a test value and critical values. It shows them all that theory. Well, why would you do that? It's so much easier if you just plug it into the calculator and hit a button and you get the answer that way. Oh, that sort of turned me the wrong way. So I said, okay, I will teach and I will go through the p-value with that and introduce that to the kids because obviously they need to know that. And I get that. But I'm not going to go through the process and change what I teach in regards to hypothesis testing because to me, this is not very difficult. It's the same steps over and repetition over and over again. But the p-value is what we'll talk about today. And once again, it's something that will show you how to deal with it. And if you want to utilize this, that is fine because the University of Findlay obviously goes through this. And I will ask you today to look at your p-value. The p-value is the area under a standard normal distribution curve representing the probability of a particular sample statistic. That's your p-value. And as I've gone through this, and Mr. McFerrin asked me to help him with the statistics when he was going through his master's courses. Okay, and he also talked about some of his readings that they had to do. And a lot of the readings that they have to do talk about p-values in there also. So it's an area under a standard numbers curve representing the probability of a particular sample statistic. The p-value is the area outside the area arrived at from a z-score. The p-value is the area outside the area arrived at from a z-score. This is a little bit easier to understand for us, what we've talked about. Because we've talked about z-scores, we've talked about normal distribution curves and bell-shaped curves. So basically what you're looking at here is, I will take a look at the last example. We have 2.716. Our z value that we calculated was 2.716. The p-value is this area right here. So I look at my bell-shaped curve, it's the area that's outside. If I would look up 2.72 on my normal distribution curve, I would get an area of 0.4967. So I have z is equal to 2.72. My table value would give me 0.4967. To calculate this area, we would have to take 0.5 minus the 0.4967, which is 0.0033. So there's a lot of manipulation has to go along with this. What do we do with that value we just calculated? The p-value outside the area of the z-scores. To calculate the p-value, we calculate our z-score. This is our test score. We calculate the z-test score, which we did, 2.72. We go to our z-table, determine our area, which is what we did. We subtract that area from 0.5, which is what we did. That gives us our area on the outside. Okay, these are all things that we've done already when we started looking at z-table. Now to calculate the p-value, we have two scenarios. If this is a one-tail, this is your p-value. If this is a two-tail, you need to multiply this by 2. One tail, that's our p-value. Two tail, we multiply by 2 because we have to do both these values over here. We have two tails. So our p-value in this case would be 2 times 0.0033, which is 0.0066. That is our p-value. If your p-value is less than the alpha value, you reject the null hypothesis. If your p-value is greater than your calculator, or greater than your null, or let's try that again. If your p-value is greater than your alpha value, then you fail to reject the null hypothesis. Well, our alpha value in this case was 0.05. So we reject the null hypothesis. So basically, you're comparing your p-value to your alpha value. Now the question is, that's a lot of work to find your p-value. And before the advent of calculators, it was a little bit more of a challenge. But as my teachers up in Finley said, well, it's a lot easier. Just why wouldn't, I mean, it was very condescending in how they looked at me and said, why would you do that? I was like, sorry, I'm just teaching fundamentals of your class. It was, anyways. They're no longer there. Let's look at the calculator. Let's look at your calculator. Now, once again, it's going to be a little different for you. Okay? But you'll be able to find this in your stat mode. If we go to your stat mode, and we're just going to look at the last problem here. We've dealt with editing. We've dealt with one variable statistics and calculated. Let's go over to tests. So hit your right arrow. Let's go to a test. We are dealing with z-test because our sample size is greater than 30. So we're going to z-test. Okay, so your z-test comes up. You should get a screen that looks like this. We can either do it from data, from L1, or we can just add in our statistics. So let's go over and make sure statistics is highlighted. Our mu naught, okay? What's our null? We're going to, our mu is equal to 39,385. So we type that in. Our standard deviation that we use, 59.75. Our sample mean that we're utilizing, 41,680. Our sample size we're dealing with is 50. So we're just entering in the information. All right? We look at our alternate hypothesis. Alternate hypothesis we're not equal to. So make sure that is highlighted. Mu is not equal to mu naught. Oh, I need to do one other thing here first. Here. Yeah. Now let's go down to the very bottom and let's draw. Highlight your draw. And hit enter. We get our bell-shaped curve. We get our z-test score, which we calculated to be 2.716. And we also get a p-value. This is why they say, well, why don't you just use your calculator to plug in your calculator? Why do that in mathematics? Once again, I'm an old school person. Just how I am. But it will give you a p-value. And that p-value, then you can make an evaluation then where you're at. What I still want to see is I want to see a test score and a bell-shaped curve here. Okay? And a critical value. At that point, if you go and calculate a p-value and utilize that as your evaluation, then it's fine. This is also a good little check for your z-test score that you calculated. And once again, if you want to utilize a p-value, now if you don't have a TI calculator 84, like Adam over here, then to find your p-value, you would have to go through this right here every time, which is doable. It's not difficult to do. But you have to remember, if it's two tail, you multiply by 2. If it's one tail, that's your p-value. That's what you have to remember. So what I want you to do for your homework is go back to the problems that you've just done. Calculate the p-value. Put a p-value down there. Whether it's using your calculator here or you want to use your z-table, you're able to figure out your hypothesis testing on that. Okay.
I have to do online.
Yeah, I'm sure there's something there that will allow you to put in for hypothesis testing. I'm sure it's somewhere. You just have to find it.
Is this gonna hurt me in college? Like
No.
they're doing like some
What?
math thing. They say everybody get out your calculator.
Okay. What 3 letters do I always say when we pull out our calculator?
KYC.
Okay, know your calculator. Okay, whatever your calculator is, if you know how to manipulate through your calculator, you'll be fine. I would doubt that, because it's an advanced calculator still, that it will not. And it's very unlikely you wouldn't be able to do your hypothesis testing on that. You should be able to find something in there that allows you to do your hypothesis testing. And if not, then yes, that might be something that you might want to take a look at eventually. But I would be surprised if it's not somewhere in there.